I'm going to talk about some results of our experiment using the method that Paul Bogowski has just presented for evaluating the perceived air quality. And we use that to evaluate several air cleaners. The experiment consists of 2 stages. We use this methodology to evaluate the perceived air quality on those air cleaners. We use this to clean the indoor air. In the first stage, we want to select those air cleaners at least will not deteriorate the indoor air quality, because some air cleaners may smell itself. So this kind of air cleaner, we don't want to test them. So in the first stage, we select 3 different types of air cleaner. The first one is ionizer. The second one is solvent air cleaner, which include a HEPA filter and charcoal filter. The third one is active air cleaner, which is based on some chemical reactions to oxidize the chemicals to decompose them. The manufacturer of the air cleaner did not release all the technical details to us, so we don't know exactly how it works. But they told us that there is a ozone generator inside, and there's a UV light. So we assume that's based on UV ozone reaction, because that generally generate a lot of radicals, which is a very strong oxidant. So we try to first screen these 3 kind of air cleaners and exclude if any of the air cleaner itself pollute the air, then we'll not make any further test. And during the test, we use 2 group of pollution source. One is the building material. Mostly these are some carpet and other flooring materials, like linoleum and some PVC flooring material. And we also use human biofilms. We use the real human subject as a pollution source. The reason to use these 2 kind of pollution source, one is that these 2 pollution sources are the major pollutants occurred indoors, and we can use them to mimic the real chemicals in the indoor environment, because this is combined with many chemicals, maybe hundreds of chemicals. So we don't test with only particular chemicals in the air. And another reason also, because if we dose particular chemicals, usually this kind of experiment, we have to get it approved by the ethics committee. But we get a general approval from ethics committee that if we use any of the material which is commercially available in the market, then we don't have to apply for special permission. And we test, this figure shows the setup of our experiment. We have 3 testing rooms. In the middle of the testing room, we put a partition so that people cannot see what is arranged behind the partition. And behind the partition, we put air cleaners. And also in one of the room, when we have we use human biofilms as a pollution source, they also sit behind the partition so that the sensory subject cannot see them. And one of the room is polluted by building material, and this was loaded in a special cabinet, and we have a ventilation to take the air went through this material and to carry the pollutants out from the material, and then they were distributed into the room with two fans, so it's well mixed in the room air. And in all three rooms, we have the same cabinet, so people do not know which room has the material or which is not. So when sensory subject enter this room, they will stand in this locations with the cross, with the green cross, and evaluate air quality using the questionnaire scales showed by Pawłowski. So we ask them to assess the acceptability of the air and also odor intensity of the air. And we during the experiment we made also facial exposure. This was assessed outside this test room. So we have we use some duct to get the air into the room and then into a special diffuser for human exposure. And this is only the facial exposure. So the sensory subject put their nose into this diffuser and assess the air quality. And totally we used around 35 sensory subjects to assess the air quality. And the room was ventilated with different ventilation rate, mainly according to the EU standard, 4 liters per second per person, 7 liters per second per person, and 10 liters per second per person. So this picture shows how the subject assess air quality. The one in the left-hand side, this is for the full exposure. They enter the room and stand on this cross, and they assess the air quality and vote on the questionnaire. And the picture on the right-hand side, it shows the facial exposure. When the people goes to these special diffusers, they put their nose on the diffuser and assess their quality. So here's some of the results. For the first stage of the experiment, we mainly focus on whether the air cleaner itself will pollute the air or not. So these are the 3 results when we ask the subject to assess the odor intensity of the air. As you can see, the figure in the right, the figure in the left, showing the room without building material. I mean, without additionally added building material as a pollution source, and also without people sitting in the room. So it's we call it empty room. And then we turn on the air cleaner and turn off the air cleaner and let the subject assess the air quality. And this is the odor intensity assessment. And you can see there's not much difference when we use the first air cleaner, which is the ionizer. So let's say in the empty room, whether we use ionizer or without running the ionizer, the odor intensity in the room do not change much. The green bar shows the odor intensity in the room with the air ionizer, and the gray bar shows without ionizer. It seems the odor intensity increased slightly when we ran the ionizer, but the difference is not significant. The same when we use other pollution source. There's not much difference on the odor intensity assessment. This shows when we use the second air cleaner, which is activated carbon air cleaner. And it looks like for the empty room, also the odor intensity increased slightly. But when the room was polluted by people or by building material, the odor intensity did not show increase when we operate the air cleaner. And when we use the building material as a pollution source, the odor intensity decreased. And this is test results of this air cleaner based on the UV ozone reaction. And here we observe a significant increase of odor intensity when the room is empty. So that means this room has very low pollution level, But when we run the air cleaner, suddenly the air cleaner itself smells. Then people can clearly smell this, and the odor intensity increase a lot. Also, when we use people as a pollution source, we also observe this significant increase in the odor intensity. So this means this air cleaner actually itself has a significant pollutants, increase pollution, odor intensity in the room, and this is mostly due to probably we try to observe and try to find the reason. First of all, this air cleaner is based on this ozone UV reaction, but it is not allowed to release ozone into the room. So in the air cleaner, it put an catalyst at the outlet to absorb all the residual ozones. So actually, the air cleaner itself do not release any more ozone. Actually, the ozone concentration at outlet is even lower than at the inlet. So it effectively removed the ozone. But the odor could come from this catalyst, because the catalyst itself smells. And also, maybe this ozone UV reaction with these chemicals generate some other chemicals which also smells. And this remains for further investigation. But anyway, this air cleaner was excluded for the further test in our second stage of the experiment. So in the second stage of experiment, we made a detailed test on these air cleaners at different levels of ventilation rate. And in this stage of experiment, we use also 3 air cleaners. The first one is the same ionizers, and the second is the same air cleaner with charcoal filter. And we include another air cleaner also based on the charcoal filter. And we use the same pollution source. But this time we have the 3 rooms loaded with material, with human subject and both. And the experiment was run at the 4 levels of ventilation rate, 7.5 liter per second, 12 liter per second, 21 liter per second, and 30 liter per second. This corresponds to 2.5 liter per second per person, 4, 7, and 10 liter per second per person. Because when we use human subject as a pollution source, we have 3 persons sitting in the room. And this is the experimental setup, which is more or less the same as in the first stage. And we have both full exposure and facial exposure. So here, some of the results I can show here. And this shows the results of the acceptability scale for the ionizers, when we use ionizer as air cleaner. The figure on the left-hand side showing when building was polluted by building material, and the figure on the right-hand side showing that the air was polluted by human biofluence. And as you can see, the acceptability of the air at these 4 levels of ventilation rate, 2.5, 4, 7, and 10 liters per second per person. At the low ventilation rate, it doesn't show much improve in air quality, slightly improve at the very low ventilation rate. However, at 7 liters per second per person of ventilation rate, suddenly the air quality decreased with using this ionizer. And when the room was polluted by human biofluence, normally we can see the picture is that the air quality is getting worse when using the ionizer as air cleaner. The lower part of figure showing the acceptability assessed by facial exposure, and compare the figures up and down, we can see that the facial exposure, when we use facial exposure to evaluate air quality, it looks like the air quality improved. So the facial exposure has a positive assessment on the air quality compared to the full body exposure. And this is the results of the the odor intensity assessment. The same, there's not much significant difference, but we could see that at 7 liters per second per person of ventilation rate, the reason that acceptability of the air decreases is actually due to that when we run the air cleaner, there's a higher odor intensity. So that probably explains why the air was assessed as less acceptable. And we compared also some chemical measurement, because at the same time we did chemical sampling and did some chemical analysis. And we found this figure shows the measurement of aldehyde. The green bar shows the results with air cleaner, and the gray bar shows without air cleaner. And there's not very much difference. So that means air cleaners of this ionizer did not remove any of the aldehyde from the air. For general VOCs like TVOCs, it looks like VVOCs decreased, while others, VOC and VVOCs, VVOC decreased only when the air was polluted by building materials. When the building was polluted by people, there's almost no change on both VVOC and VOCs. And we tried because there's many chemicals in the air. We couldn't analyze all of them, but we tried to identify those major peaks from the chromatograms. So we made a calculation, we subtract those finds when the room was not cleaned by the air cleaner, and the other one with the room was cleaned by air cleaner. So we try to subtract these two and see what are the difference. And as we can see, we identified like 56 compounds from this chromatogram, and we found that when the room was polluted by building materials, quite some compounds were removed. While when the room was polluted by human biofluence, you see there's both positive and negative. That means using air cleaner could remove some compounds, but also it could generate some other chemical compounds. This is the results for these ionizers. So the second test is for these charcoal filter air cleaners. And here we can see a clear improvement on perceived air quality when the room was polluted by building materials. The acceptability assessed in the room with the air cleaner, which is showed by this orange bar, shows much higher acceptability compared to the room without air cleaner. In the room with human biofluence, the same trend, except when at 7 liters per second per person, the air quality did not show improved. However, this is slightly significant. In the room where the pollutants are a mixture of building materials and human biofluence, we didn't observe much improvement using the. We see improvement not at the low ventilation rate, but at high ventilation rate, we observe some improvement. And again, compare with facial exposure and the full exposure, slightly improved with facial exposure. This is also the odor intensity assessment, and it shows the same for the building material as a pollution source. We can find the odor intensity decreased when we operate this charcoal filter air cleaner. The same, we compare the chemical measurement. This is also the results from the aldehyde measurement. and we found that this air cleaner did not remove much aldehyde. So aldehyde concentration with and without using the air cleaner is more or less the same. However, we found that both VOC and VVOC decreased when operating the charcoal filter air cleaner. In all these three rooms with different pollution source, building materials, human biofluence, and building materials plus human biofluence. The same compared with the chromatogram of the chemical measurement, we found that by running the air cleaner, most of the chemicals can be removed. That probably expands the positive effect of this charcoal filter air cleaner to improve the perceived air quality. The third air cleaner is also the charcoal filter air cleaner, and it shows more or less the same trend as the other charcoal filter air cleaner, except for this condition when the air in the room is polluted by building materials and human biofluence. At 7 liters per second, suddenly we found that running air cleaner decreased the acceptability. The reason for this is still under investigation. But we suspect that it's probably because of the pollution subjects. We try to encourage them, for example, to take a shower every day and don't eat any smelly food and don't wear perfume. But some subjects may not strictly follow our instruction, and that probably could be explained to this strange results. For the odor intensity assessment, and also it shows this is because the odor increased in this condition with 7 liters per second per person. Chemical results, actually this shows for the aldehyde, this air cleaner removes some aldehyde and also remove VOCs and VVOCs. And also the chromatogram comparison with, it shows also this air cleaner remove most of the chemicals, except this one, the first one, this is ethanol. And this is most probably due to in that period, because many people using ethanol to clean their hand. Probably suddenly someone used ethanol and that get into the room. When we compare the results to summarize whether the air cleaner can be used to replace ventilation, we calculate the CADR. And this curve, this is odor intensity in relation to the airflow, the ventilation rate. The red curve shows the odor intensity in the room without air cleaner, and blue shows the odor intensity in the room with air cleaner. And here you can see the CADR at lower ventilation rate is higher than the CADR at high ventilation rate. And when the ventilation rate further increase, they cross, these two curve cross to each other. That means if you have very high ventilation rate, then the air quality in the room is good anyway. So whether you operate air cleaner or not, it will not improve the air quality. And this shows the percentage of dissatisfied in relation to airflow. And here we saw a huge CADR. But I have to point out that in this experiment, in order to observe the effect of air cleaner, we put 3 air cleaners in one room. And this room has about 16 square meters. So actually, it should be 1 air cleaner should be enough. So that explains why there's here so high CADR, because 3 air cleaners using in the room. And for comparison, we between the whole body exposure and the facial exposure, we found that the facial exposure always assess air quality which is better than full exposure. And this is this figure on the left-hand side showing the odor intensity. It seems like facial exposure assess the air has a lower odor and also on the right hand side it shows the facial exposure says the air in the room is more acceptable. So my conclusion is, while the facial exposure looks like has underestimate on the odor intensity and assess the air quality better than the full exposure, and the air cleaner with activated charcoal filter has a clear effect on removing the VOCs, reduce odor intensity, and improve the perceived air quality. The human biofluence, from this experiment, it shows it's quite difficult to be controlled. It's very much depend on those human subjects, the pollution source, if they are strictly following our instructions. But we found that some of the subject maybe they follow our instruction, but maybe due to their living habit, maybe in their home they use some fragrant and they have this smell in the room, and these smells get into their clothing, and so it's quite different. So we think using human subject, you have to be very careful control, otherwise you may get some strange results. So that concludes my presentation. Thank you for your attention.